Hello, this is Mrs. Ward, and I'm going to go over a couple problems from section 2.4, the chain rule. So hopefully this will help you when you complete your book work. So number 3 asked you in exercises 1 through 6, they want you to complete the table. So they want you to find G, they want you to find U, which is G of X, and then they want you to find Y, which is the function that you're taking of U. So in other words, G of X is the innermost function. So in this case, the innermost function is going to be that X squared minus 1. So that will be my U. And then Y will be what I'm doing to U, or what function I'm taking. So Y would be the square root of U. So when I go to use the chain rule, I'm going to take the derivative of U, and then I'm going to take the derivative of what's inside. So let's start with number 9. I have G of X is equal to 3 times the quantity of 4 minus 9x. That whole thing is raised to the 4th power. So if I'm going back to that previous example, my most inner function is going to be that 4 minus 9x. And the outermost function is going to be something raised to the 4th power. So when I do the chain rule for this, I'm going to say G of X is equal to taking the derivative of this first, the outermost function. The derivative of that would be 4 times U raised to the 3rd power. So I'm going to leave this 3 outside using that constant multiple rule. And then I'm going to have 4 times 4 minus 9x. And this whole thing is going to be raised to the 3rd power. And then I'm going to take the derivative of what's inside. So take the derivative of U. So the derivative of 4 minus 9x would just simply be a negative 9. So this will be times negative 9. Now I'm going to multiply what I can. So everything's being multiplied, the 3, the 4, and the 9. So I can multiply all those constants together. I'm going to do that again, negative 108 times the quantity of 4 minus 9x, and that whole thing is raised to the 3rd power. And that is my derivative. And now let's move on to the next one. So the next one, I'm still taking the derivative. My innermost function is going to be that fraction, that t squared over t to the 3rd plus 2. So when I take the derivative of that, I'm going to have to use the quotient rule to take the derivative of that. And then the outermost function is going to be something raised to the 2nd power. So I'm going to do this first. To take the derivative of this, I'm going to take 2 times U to reduce the power by 1, so that would be 1. So applying that over here, I'm going to take 2 times this quantity of t squared over t to the 3rd plus 2, reduce the power by 1, so 2 minus 1 would just be 1. And I can write the 1 or not write the 1, totally up to you. Now, once I've taken the derivative of the outermost function, I need to take the derivative of the innermost function, in other words, of this. So I'm going to have to use the quotient rule. So using the quotient rule, I'm going to leave the denominator alone, so that t to the 3rd plus 2 stays the same. Take the derivative of the numerator, which will be 2t, minus take the derivative of the denominator, which will be 3t squared. Leave the numerator alone, so that would be t squared. And this is all over the denominator, which is t to the 3rd plus 2, that whole thing squared. Now I'm going to multiply. So when I multiply, this 2 is understood to be over 1. So I'm going to have 2t squared times this quantity of, I'm distributing this 2t, and I'm going to have 2t to the 4th plus 4t. And then when I distribute this negative and this t squared, this will be minus 3t to the 4th. And this is all over this t cubed plus 2 times t cubed plus 2. So that will end up being t cubed plus 2. That whole thing is going to be raised to the 3rd power. That's a 3, a really bad 3, but a 3. Cleaning up what I can in here, so I see that 2 to the 4th and negative 3t, that'll be negative t to the 4th plus 4t. So I can factor out 2 from the numerator. So when I factor out that t from the numerator, this will now be 2t to the 3rd because I factored 1 out. And I'm left with negative t cubed plus 4. And this is all over my denominator, which is t to the 3rd plus 2 to the 3rd power. And that's an example of using the chain rule with the quotient rule. Moving on. This one wants me to find the derivative of a function. So my innermost function is going to be, oh, wow, I guess I have u squared. Well, I have something squared, but then that thing that I have squared, I have to use different letters. So I could say u would be pi times x. Then I have u squared, so that would be my y. And then I'm going to have a function outside of that. Let's call that, I don't know, g, lack of letters. And that's going to be the sine of y. So I have three things going on here. So I'm going to go from the outermost to the innermost. So the outermost thing, the outermost function I'm doing is this sine of x. So I'm going to take the derivative of sine of x, which would be the derivative of sine of x is cosine x. So this will be cosine pi x squared. And remember, this squared symbol only goes to the pi and the x. So it's kind of like, side note, it's kind of like I could write this as sine pi squared x squared, just so you realize that that's why I took the sine, I took the derivative sine first. Now I am going to take the derivative of something raised to the second power, so times, so I'm taking the derivative of this, which would be 2 times pi x, and then to reduce the power by 1, so that would be just times 1. And then the last thing I'm going to do is take the derivative of this u squared, or this pi x, and the derivative of pi x, remember pi is a constant, so that would just be pi. So those are my three parts because I have three things going on. I'm taking the sine function, I'm squaring something, and I'm multiplying the x by pi. So three things are happening to x. So when I put all this together, I'm going to have 2 pi squared times x, and then times the cosine of pi x, and that whole thing is squared. And that would be my derivative. Remember, I have three parts or three links to this chain. Okay, 52. I'm taking the cosine, I'm taking 5 times the cosine squared of pi times t. Again, I have three things going on here, so I'm just going to rewrite this to make this clear. The difference between the last example and this example, this is 5 times the cosine of pi times t, and since that squared symbol is there, that means this whole thing is squared. So three things going on. If we want to start with u would be pi times t. Pick another variable. Oh, I don't know. Let's say y would be u is squared. Oh, no, did that wrong. Stop me. The next thing that I have going on is that the cosine, so then I would be taking the cosine of u, and then let's just go with g, that worked last time. And the last thing I have to do is I am going to be taking that y squared. So those are the three things that are happening to the t. It's being multiplied by pi, it's taking the cosine of pi times t, and then it's being squared. So I'm going to do the chain rule from the outer to the inner. This 5, just coming along for the ride, it's going to stay outside the entire time. So I can do the 5 here and just put a bracket just so I remember to bring that 5 down with me. So taking the derivative of something squared, that would be 2 times the cosine of pi t. Reduce that power by 1, so that's just going to be raised to the first power. Then times, now taking the derivative of cosine, which is negative sine, and then that's pi times t. And then taking the derivative of pi times t will just be pi. So those are my three parts. Whoa, there's my lovely family. Okay, so then you're going to go and you're going to multiply these. I'm going to multiply that 5 with it while I'm at it. So I'm going to have 5 times 2 times the negative sign times pi. So that'll be negative 10 pi. And then this is a cosine of pi times t. Times the sine of pi times t. And I'm happy if you get there. The book is remembering an identity, which I'm sure most of you don't remember, but the book is going to rewrite this. Don't worry about it. Just leave it like that. If you check the answer in the back of the book and you see something like the sign of 2x or the sign of 2t, know that they're using one of those properties that you learned last year in honors. Check with Miss Bella and you get all those that you need, so we're not going to worry about that. Okay, exercise 59 through 66, you're going to evaluate the derivative of a function at a given point, and then you can use your calculator to check your results. So I'm going to find the derivative of this. I am going to rewrite this because I don't know why I rewrote 61, but I'm going to rewrite this as 3 times the quantity of x to the third minus 4 raised to the negative 1. I've just rewritten it instead of having, I brought the 3 out in front, and then instead of having the fraction, I just wrote it with a negative exponent. I'm still going to have to take the chain rule, but I'm not going to have to do the product rule, which I think is a lot easier. So when I take the derivative of this, that 3 is just out there for the ride. Negative 1 comes out front. X to the third minus 4. Reduce this power by 1, so this will be to the negative 2 power. And then multiply by the derivative of what's inside, so this will be 3x squared. Now when I clean it up, I'm going to 3 times the negative 1 times 3, so this will be negative 9x squared all over my denominator, which is x to the third minus 4, that whole thing squared. And then I want to show you how you do this on your calculator, so give me a second. There's my lovely family again. Yep. Okay, we have a guest speaker.
Hello, everybody.
All right, that was my daughter Sarah, who's now going to leave the room, and we are going to find. It wants to find us to evaluate the derivative at this point. So now I have to take that negative 1 and substitute it in. So to find the derivative at negative 1, I'm going to put negative 9 times negative 1 squared all over negative 1 raised to the third power minus 4, that whole thing squared. And when I do that, I get a negative 9/25. So you can check this on your calculator. So if you get your calculator out, and again, I apologize, it's so tiny and I don't know how to fix it. You're going to hit menu, and then you're going to go to calculus, and then it's going to be numerical derivative at a point, and that's the only time you can find the derivative of your calculator is at a certain point. It wants to know the variable. I always leave it as x. Then it wants to know at the value. So it wants to know the value at x, and it was at negative 1, so I'm going to put in negative 1 here. And then I'm going to go down to OK. And then it's going to have the d of x, which is the same thing as the derivative notation. And I'm going to go back to my original equation. I'm going to type that in. So using my favorite button, my control divide, I'm going to type in 3. And then my denominator was x to the third. Oh, that's not what I wanted to do. Oh my. Not going to give up. Not going to give up. Oh. Okay, so now I've typed that in correctly. That took a lot longer than I thought. So you have that, and you're just going to hit enter, and you're going to get that negative 9/25 that we just got. So that's a great way to check your answer. Even if you're just asked to find the derivative and you're not sure, you can pick a value and see if you get the same number, and then chances are you took the derivative correctly. Okay, moving on to the next one. We have, it says, find the equation of the tangent line of the graph at a given point, and then you're going to use your graphing utility to find the tangent line, and you're going to graph it, and then use the derivative feature that I just showed you to confirm your results. So 69, I'm going to take the derivative. The outermost function is something being raised to the second power. That u is going to be the 2x to the third plus 1. So when I take the derivative, I'm going to take 2 times the 2x to the third plus 1 raised to the first power, because I reduced the power by 1. And I'm going to multiply that by the derivative of 2x to the third plus 1, which will be 6x squared. When I clean that up, I'm going to get 12x squared times 2x to the third plus 1. So that's my derivative. In order to write the tangent line, I need to find the derivative at this point. So I'm going to substitute in that negative 1. So when I do that, when I take the derivative at negative 1, I'm going to have 12 times negative 1 squared times 2 times negative 1 to the third plus 1. When I do all that, I get negative 12 for my answer. Remember, that's my slope. Now when I go to write this in slope-intercept form, I'm going to do y minus my y value, which is 1, is equal to my slope times x minus my x value. So when I write all this, I'm going to get negative 12x minus 11. And that's the slope of my tangent line. So when you do this, you're going to go back and you're going to type in your original equation. You're going to type in this line. You're going to see if it looks like it's tangent. Then you're going to use that derivative function at a point on your calculator and see if you really get negative 12 at negative 1. Moving on to the next one, I have same thing. I have the tangent squared, and I'm going to think of this as the tangent of x, that whole thing squared. So my outermost function is something being squared. My innermost function is taking the tangent of something. So same directions as before. So when I go to take the derivative, I'm going to have 2 times the tangent of x, reduce the power by 1, so it'd be 1, times the derivative tangent of x is secant squared x. So now when I find, that's my derivative. Now when I find my derivative at my x value, which is pi over 4, so we'll do pi over 4 here. I'm going to take 2 times the tangent of pi over 4 times the secant of pi over 4, whatever that value is, I'm going to square it. So when I do this, this will be 2. The tangent of pi over 4 is 1. The secant of pi over 4 would be the square root of 2, and I'm going to square that. So that would be 2 times 2. So the whole thing would be 4. So that's the slope of my tangent line. Here's my slope. Now let's go and put it in slope-intercept form. So I'm going to say y minus my y-coordinate, which is 1, is equal to my slope, which is 4, times x minus my x-coordinate, which is pi over 4. So when I do this, I get y is equal to 4x minus pi plus 1, and that's my slope of my tangent line. And then you would graph the original function, you would graph this tangent line, make sure it sort of checks out. Check it on your calculator. You're going to do the derivative at a point, and your x value for that point is going to be pi over 4. When you do all that, you should get 4 for your answer. Okay, numbers 83 through 86 are just asking you to find the second derivative. So this one, when I'm doing this, remember the x is just the only thing that's squared, not the sign. So my first function, my outermost function, is taking the sign of something. So when I take the derivative of that, the derivative of sine will be cosine, and that's positive. So this will be cosine of x squared, times the derivative of x squared would be 2x. So rewriting that, I'm going to say my first derivative is equal to 2x times the cosine of x squared. Then to take the second derivative, I'm going to take the derivative of the first derivative. So to take the second derivative, now I'm going to have to use the product rule because I have this times this, and I'm going to have to use the chain rule for this. So I'm going to leave the 2x alone, and then I'm going to multiply it by the derivative of cosine x squared. So the derivative of cosine is negative sine x squared, and then the derivative of something x squared will be 2x. And then this is going to be plus. Now I'm going to take the derivative of 2x, which is just 2, and leave the cosine of x squared alone. Now when I multiply these two, I'm going to get 4x squared negative sine x squared plus 2 cosine x squared. I guess I can factor out a 2. And I can factor out 2 and make this 2. And then cosine squared x minus 2x squared sine x. Oh, sine x squared. Oh, my bad. Let me fix it. Maybe nobody knows. That should be x squared, not cosine squared x. Okay, and that's my final answer. Just wanted the second derivative. Then when you go on to 87, it wants you to evaluate the second derivative at a given point. So I'm going to go ahead and find the first derivative. The first derivative, again, the outermost, I don't even know what I'm writing anymore. The outermost function is going to be taking something to the third power. So here I'm going to leave this 1/9 on the outside. Taking something raised to the third power will be 3 times 3x plus 1. Reduce that power by 1, so this will be squared, times the derivative of what's inside, which will be 3. So when I take 1/9 times 3, that's just going to be 1. So I'm going to be left with 3x plus 1. That whole thing squared. Then when I take the derivative of that, for the second derivative, switching colors, second derivative is going to be 2 times the quantity of 3x plus 1. Decrease the power by 1, so that'll be 1 times the derivative of what's inside, which will be 3. Then I am going to get 6 times 3x plus 1. And it wants me to find the derivative at a point which is 1. So to do that, I substitute in 1. That's some really bad writing. And when I do that, I get 6 times 4, which will be 24. So my final answer is 24. It says computer algebra system. You don't have that, so you can't check it on your calculator. I mean, you can do some workarounds, but you can't just directly substitute that in. Okay, number 100. Here we go. So this one you're asked to find. You're using this graph, so you don't have the functions, and it's asking you to find the derivative, and they're telling you h of x is f of g of x, and s of x is g of f of x, and they're asking you to find the derivative using this picture, and then if it doesn't exist, because there's some places where the derivative doesn't exist, like here, I can't take the derivative there. So if we're going to use that, then I can't do the problem because that derivative does not exist. So I am going to write these problems down. So what I did is I pulled this from your notes, and I'm looking at the bottom here. So this is what you're doing. You're separating f of g of x as the derivative of f of g of x and g of x, which means that when I do this, I'm going to write just like it's written there. So I'm doing f derivative of g of x times the derivative of g of x. So the derivative of g of x is fairly simple. So this one's of 3. So I'm doing f of g of 3, and then g, the derivative at 3. So the first thing I'm going to do is I'm going to find what g of 3 is. So here's my graph for g. I'm going to 3, and it looks, so I'm looking at this point here, and that looks like it's 5. So I'm going to find the derivative of f at 5 times the derivative of g at 3. So that's my final problem. So to find the derivative, remember I want to find the slope of the line at that given point. So let's do the derivative of f, so the darker line, at 5, which is here. So I want to find the slope of this line. So I can see that it goes from here to here. So my rise would be 1, 2. My run is 1, 2, 3, 4. So that ends up being 1/2. Then to find G of 3. So now I'm looking at 3. Let's switch colors here. So 3, I'm looking at 3, which is here. And I want the derivative of f. Oh no, G. I want G of 3. So I want the derivative at this point. So I'm going to go up 1, 2 over 1, 2. So my slope is 1. So when I multiply 1/2 times 1, I get 1/2. So that's my answer for the derivative of h at 3. So that's all the work for that one. Now let's go do the next one, which is s of 9, derivative of s of 9. So this one is still using the same functions, but the inner one becomes the outer one becomes the inner one. So we're flipping the order. So I'm going to write it just the way I did here. So s, the derivative at 9, is going to be g, the derivative of g of f of x, times the derivative of f of x. So this is all 9. So g of f of 9. I think it makes it so much easier if you actually take the time to write it like this, but what do I know? I've only been doing it for 30 years. Okay, so I'm taking the f of 9, so I find f of 9, so here's 9, go up to f of 9, and that looks like it's about 8, so I want the derivative of g at 8 times the derivative of f at 9. So now I go to, I'm going to erase all these. So now I go to G, so I'm looking at this line, I look at 8, so I want the slope of this line here, which if I go from this point here to this point here, it's like I go down 2 and over 2, so that slope is -1, and then the slope of f at 9, so I'm here at 9, so I want the slope from here. Slope of this, well, I'm just going to go from these 2 points. It's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. So that looks like it's, my rise is 8, so 2 over 4, and then I get a -2. And I think that's the best way to do those. But again, what do I know? And that's it. We're done. Oh, good for us. So, if you have any questions on specific problems, email me. I'd be more than happy to either meet you in the collaborative room or send you an email or do another video. Just let me know what you need. All right, have a great day.